Hey guys, Professor Doney back again for probably one of the last videos here for horizontal motion, and then we'll go vertical. So we're going to do a quick problem here and talk about going at constant velocity. Alright, constant velocity. Okay? Constant velocity just really means that my final velocity, or where I end up, is the same as where I started, which is going to be a constant value or just a fixed value. We could say it's the same thing as setting the cruise control, CTRL for control, in your car. So 1 second you're doing 30, a couple seconds later, hey, you're still doing 30. We call that constant velocity. Okay? So when we have constant velocity, what it means is I take my final velocity minus my initial, I'll get 0. Because it's 30 here and 30 there, or 60 miles an hour there, and then we're still going 60 later. There's no difference, so we say that our change in velocity equals 0. Therefore, if my change in velocity is 0, over time it doesn't matter what time or how long we wait, we still get 0. And change of velocity, as we saw earlier, is equal to acceleration. So constant velocity just means if we're on cruise control, we're not speeding up, we're not slowing down. That means our acceleration is 0. Now there's two things that can happen when our acceleration is 0. One, we are at rest. We're not moving. We have no velocity to begin with, and we have none later. The other one is that we are going at cruise. We set the speed and it stays at that if you use that in your car. So if we had if we're doing a problem and we're talking about car going at a constant rate of, let's say, 20 meters per second, and we're going to do that for a period of 10 seconds, so that's about 44 miles an hour, and we do that for about a 10-second period, we want to know how far away we are. Now we can go back up to our three equations. Let's do that. Let's pick a different color here. I'll put the three equations up there quick. V equals VO AT. V squared equals VO squared 2A delta X. And then we have that last one, which is delta X equals V0T plus half AT squared. So there's our three equations. And they still apply because we're talking about motion. Now what changes about them, since A equals 0, a lot of these equations drop out, or the terms in the equations drop out. So if I change this color once again, we see that up here this goes away, that term goes away, that term goes away because A equals 0. And what we're left with really is this equation that is useful. So if I want to know how far away, it's equal to my initial velocity times how long I've been doing that. So if our initial velocity is 20 meters per second, and we're doing that for 10 seconds, the seconds drop out, we're left with meters. It tells us that the car or the object will travel 200 meters in that time frame, going at a constant rate, or an average rate of 20 meters per second. So that's a special case of motion where we're not accelerating, and we do have an initial speed here of 20. And if we continue, that's like those old train problems you probably had in high school where it said, or grade school, it said a train leaves Chicago going at 60 miles an hour, travels for 1 hour, how far away is it? You're basically doing distance equals rate times time. Here we write displacement is velocity times time. Same thing. So there's a quick one on how to answer that. Hope that helps out. We'll see you in the next one.